In this video, I'll demonstrate how to read GPS coordinates from a GlobalSat GPS EM506 receiver to a Texas Instrument F28069M Launchpad experimenter's board using the Altair Embed application. The EM506 is a low-cost GPS receiver available from SparkFun. It receives power and communicates through a JST-SH vertical 6-pin connector. The SparkFun GPS breakout board accepts the EM506 JST-SH vertical 6-pin connector and routes the connections to through-hole terminals which accept a standard 0.1-inch header pin. To connect the EM506 to the launchpad, 4 of the 6 connector pins are used. Pin 1, the ground connection, is brown. Pin 2, the 5-volt power connection, is red. Pin 3, the RX line, is orange, and Pin 4, the TX line, is yellow. On the launchpad, the brown ground wire is connected to Pin 22, the red 5-volt wire to Pin 21, the orange RX line to Pin 5, which is the launchpad TX pin, and the yellow line to Pin 79, which is the launchpad RX line. Note that Pins 5 and 6 on the EM506 are not used and left unconnected. The message we expect to receive from the GPS module is approximately 75 characters. The message header is $GPGGA. We'll be interested in the UTC time, the latitude, longitude, and mean sea level altitude, abbreviated MSL. Now let's create an embed model that simply tests the serial read to be certain we are receiving data. First, we'll configure the Launchpad UART to match the EM506 settings. The port is set to A, baud rate to 4800 with 1 stop bit, no parity, and 8 data bits. Since the data message is around 75 characters, we'll set the receive queue length to 128 characters to make sure we get the entire message. The RX pin GPIO is selected as 7 and the TX pin GPIO as 12. We'll need an array to store the characters as they are received, so we'll use the extern definition block to define a 300-element character array named UART databytes. Next, we'll define the receive queue maximum length to be 85 characters to make sure we're receiving some characters. When the accumulated queue length is greater than or equal to this value, the 85 characters in the receive queue are read into the UART databytes array in the store RX data compound block. The store RX data compound block is set up to execute a for loop, indexing from 1 to the queue length value. Within the store RX data compound block, the ramp block is the iteration index. At each iteration, the receive queue value is sampled and stored in the UART databytes array. Back at the top level of the model, I've output the first 50 elements of the UART databyte array. These values are displayed both in decimal and ASCII format using the display block options. Okay, let's run our model. With the update time set to 0.05 seconds, the simple serial model is code-genned, downloaded, and begins executing on the Launchpad. If you look carefully at the ASCII outputs, you'll occasionally see full frames of messages from the GPS module, which indicate the serial receive is working.